Hello, everyone. Welcome again to PyData Global 2024. I'm Conrad, one of the co-chairs of the conference, and it is my pleasure to introduce Paco Nathan. He is a computer scientist and the head of developer relations at Sensing.com, and he is also a lead committer for the PyTextRank and KGLab open source projects, and he is here to talk to us today about catching bad guys using open data and open models for graphs. Thank you, Paco. Please take it away.
Thank you. Thank you very kindly, Conrad. And I'm grateful to get to present here today. And I'm really excited about all that's going on around PyData Global over this week. My name is Paco Nathan. I come from a company called Sensing, and we work in an area called entity resolution. In particular, a lot of entity resolution practices are adjacent to graph practices, and there's, I would say, 60% of the end use cases we're involved with are in air gap environments, usually some type of chasing money laundering or fin crime or human trafficking or other types of, basically catching bad guys. So a lot of those folks really can't get up on stage and talk exactly about what they're doing because there's a lot of confidentiality. So I and my team go out and use open data and open source to illustrate what can be done, what is being done, and try to elevate more about some of the things. And we'll provide resources later on if you are interested in getting involved in this area. I should say also that my slides are online. We'll have a link that's posted, and there's a whole bunch of URLs linking into, primary sources and tutorials. We've got like 5 open source tutorials that are much longer than this talk. So definitely I try to err on the side of having too many resources linked, but check out the slides. They're online in the public, and there may be a lot of resources. So just to try to frame this, to start out with, I will talk about an area that I would typically call investigative graphs. And the idea is that you're leveraging graph technologies to find the connections, because frankly, the people who are doing the crimes are using the network to try to hide their crimes. So this area has definitely been represented in popular media. And if you haven't seen it, of course, something that's very famous was from ICIJ, was the Panama Papers. But then subsequently, they've done a lot of other work, Paradise Papers, Bahama Papers, Pandora Papers, on and on. I think Cyprus Confidential is one of the latest. And there are really fantastic books describing this area. Moneyland by Oliver Bullough is just amazing. If you want to learn about the tradecraft of what people are doing in this area with offshore corporations and dark money, it's a slightly terrifying read. Actually, it's quite a terrifying read. There's a movie on Netflix called The Laundromat, and it's starring Meryl Streep, but also has Gary Oldman and Antonio Banderas as the bad guys. And it's sort of a vignette of a lot of different parts of this whole, oligarch, kleptocracy, dark money, worldwide networks. It's a lot of vignettes showing what's going on. So definitely, I would recommend a lot of these different books and resources. I'll illustrate just real quickly one particular case, and it was almost $3 billion. It really happened about a dozen years ago. It's called the Azerbaijani laundromat. And we know that at least $3 billion were funneled out and used for nefarious purposes. There was officials in the Azerbaijani government that were moving funds and skimming money. There were Azerbaijani elites, the wealthy, who were taking money out of the country, laundering it, and then buying condos elsewhere. There was also the Russian government was involved as far as illegal arms trade. And then there were European politicians in the EU who were getting payout. And there were at least 4 shell companies. There are 4 in the UK registered shell companies that were very central to this to try to hide what was going on. And a lot of this wouldn't have been known except for somebody leaked. A whistleblower at Danske Bank in Estonia leaked documents for 17,000 transactions showing the money laundering. And there's a really good interactive visualization of this. There's an organization called the Sentry that has a nice view of this online, which they call the Aliyev Empire, basically the main two people who are beneficiaries. So this area of chasing bad guys, basically investigating financial crime, there's a lot of different type of tradecraft, but one thing you'll see commonly is where even though it's illegal to move a certain amount of a large amount of money from one country to another, there's restrictions on that, but people get around it by breaking up the money into smaller chunks and moving through intermediaries and then eventually collecting it out at some beneficiary. And so if you're only looking at individual transactions, it's very difficult to detect any of this. But if you have a graph, you can start to see the flows and sort of the aggregate, what's being moved. And of course, a lot of this is breaking the law. But investigating this kind of work traditionally has been very difficult because banks are usually, I mean, for the most part, there's a lot of manual labor going into audit. And, there's the saying that the money moves across borders, but the laws do not. And so all of the challenge of trying to find this, let alone stop it, is that it's hidden in the first place, and there's a lot of latency before investigators catch up to it. And frankly, there's a big lack of computing tools. And this is an area where, again, open data and open source have come in so handy, especially in this kind of network analytics to identify patterns of crime. I should mention also that this particular case was done 12 years ago. No one's gone to jail yet. Now, there's a data model, and I will give credit to Friedrich Lindenberg, who leads Open Sanctions. He has a really brilliant presentation here. I just got to talk to him a couple days ago, and he's quite a leader in this area. But let's just say that this is a data model you would use in general for looking at this area of crime. There are more sophisticated data models, and I will definitely defer to a friend, Alan Brown at PyData Global, has a much better presentation about more sophisticated data modeling in this area. But in general, let's look at this three-part where you've got risk data, link data, and event data. Risk data is where you have some list of known companies or known people who've been engaged in nefarious things, and we suspect that they may be doing more. Or there may be politically exposed persons, essentially politicians who are likely to be bribed. So there are sanctions lists that are operating around. Open Sanctions is one of these, and they have almost 250 different data sources. Then there's the link data, which is sort of in between, and it's what connects things together. I'll give a shout out to open ownership. We use this so much, where essentially the risk data that I mentioned, the sanctions list, those are lists. But once you bring in the link data, now you start to have connections between people and companies, between people and their associates, and now you can start to build out a graph. There's also ICIJ and there's Glyph and many others in this area, but definitely shout out to open ownership. We use so much. And then this other category of event data in this model is where you have, essentially you've built out a graph that says, we've got some suspicious characters, we've got lists of them. We've got some link data that shows what companies they're involved with, where the money might be moving through. But then the event data is basically saying, okay, something bad happened. Like there was a money transfer and this violated certain laws. Or there are payouts into like a terrorist group or something like that. Usually this category of data is very difficult to get. Oftentimes it's highly confidential. It's inside of a bank. In a case that we'll illustrate here, there were whistleblowers who had leaked some data out to OCCRP, and then they made it open. You can download it from them. So that's a flavor for a kind of way of, again, building up from open data sets into building this kind of model to have a graph to try to then detect the patterns for where this kind of crime is being committed. Let me shift to a little bit different topic, and then I'll pull these together after. So obviously, a lot of the news about contemporary AI tooling There's so much talk about GraphRAG since, I think Nebula Graph introduced this in September 2023. There's a lot of popular open source libraries like Llama Index and LangChain and others. And there's really good work there. I would definitely shout out to some friends. Waiho AI has Knowledge Graph Studio for developing graphs to be used in RAG native or agents, etc. Really, really interesting work there. And also I'll shout out to some friends at Emergent Methods. There's a service they have called Ask News, which goes out across media to pull together from news sources a lot of unstructured data that would weigh in here. And they've been doing work to do fine tuning on open models like Liner and V3 Mini and others to get a lot better performance in this kind of area. I did an article recently for Riley Media that goes in a lot more detail about the GraphRAG aspects and really understanding the fact that the word graph in GraphRAG, depending on who you're talking to, probably means at least 8 or 9 different things. And so we break that down. We try to generalize and understand that in more detail in this article. But what I'm going to talk about here is that when you are working in this area of chasing bad guys, typically these are regulated environments. I mean, certainly government agencies that are doing this, it's highly sensitive areas, highly secure areas. And there's kind of a disconnect currently because a lot of the libraries that are available, the open source libraries that are available for RAG and GraphRAG, they have taken an opinionated perspective that, just throw all your data at an LLM, the LLM will generate the graph, and then Bob's your uncle. You just take everything downstream from there. And that does not work for regulated industries. If you're trying to do an investigation, if you need to put together evidence and then put that in front of a judge for warrants or for indictments, you can't go to the judge and say, hey, the LLM told us and we're going to defer to it. That just doesn't fly. So instead, what we want to do is unbundle the process of what's going on in the graph construction and understand how to use, state-of-the-art open models at each step so that we have much more accountability, so we can explain what's going on, so we can get domain experts to add their feedback, etc., and just have that kind of audit trail for what's happening. And so that's a lot of what I'm presenting here is how to unbundle that. And also I'll throw in, there's a couple of good papers here that, the idea of just throwing all the data at an LLM and having it generate the graph, it's problematic. And it's problematic from, there's a great paper from Bosch recently looking at where it is that within specific domains, LLMs do or do not perform well. And the fact is that once you get out into the specifics of a particular domain, this is where LLMs as context engines tend to kind of fall apart. This is probably stated even better. Gail Veracruz and Sasha Luciani and Meredith Whitaker had a paper that's just brilliant, talking about essentially some of the trade-offs, the diminishing returns in different use cases. Certainly we see this in natural language, which is shown up at the top left there. Okay, so now let me shift real quick over to entity resolution. This is an area that I work in, and it's a bit more complicated than it probably seems. It certainly has a lot of different synonyms. You'll hear talks about data matching, record matching, deduplication, record linking, concordance, blah, blah, blah. Basically, this is a way to take and merge different data sources and try to find a footprint which is consistent across them of particular entities. So, individuals, people, or companies, organizations, or maybe a maritime vessel. But it really addresses a lot of critical concerns in data quality, particularly if you've got bad guys trying to hide in the data, which is part of the tradecraft. And we think of this as a way to generate a backbone for a knowledge graph. So I work at a company called Senzing. The way we look at this is for entity resolution, consider taking 2 or more structured data sources and then pulling off features from them. Again, 2 or more features that are consistent across, typically PII. So things like names, addresses, maybe some sort of identification codes, organizational affiliations, etc. And you could think that that might be simple to handle if you were all working in the same language and everything was sort of built to standards and there weren't a lot of data quality problems. But in the real world, when you're going out and doing this and looking through the records, some of the data is going to be in different languages. And so we work across, I believe, 80 different areas of globalization in terms of different languages and cultural considerations, Arabic, Mandarin, Cyrillic, Korean, etc. And we look at data quality issues in particular about these different kind of features to understand how they can be used to sort of triangulate on, again, the entities that are consistent across your data. So as an example here, if you have a name in Arabic, Abdullah Qadash, if they've done a pilgrimage, they might have Al-Hajj as a prefix. If they're a child of somebody famous, they might have bin Amir, talking about their parentage. It's the same person, might be translated, a half dozen different ways into English. But then at the bottom, you have a case like John R. Smith versus John E. Smith. If you try to compare those strings, they're only one letter difference, but clearly they're different people, especially if you're handling, like, for instance, we do a lot of work with voter registration, and you have to be really, really careful there. And so I just want to, emphasize that culture dictates a lot of how you have to make decisions. You can't just throw this at a machine learning model. You have to really break down the names, break down the addresses. That's definitely shown here, looking at like addresses in Singapore, where there's a confluence of different cultures. The addresses become very complex because of things like transliteration and abbreviations. The one at the top is the same. It's a completely different string. The one at the bottom, it's only 2 letters different, but they're completely different businesses. So you have to take that. And again, if you're working in areas like voter registration, passport control, counterterrorism, money laundering, etc., the bad guys are trying to hide this way. And the edge cases are what are important. And you have to handle it very carefully. There's some white papers. I'm not going to linger on this too much, but if you want to dig into how this works, we also have a lot of open source repos for a lot of integrations if you want to get started on things. Okay, so having talked about that, let's bring it together in the context of graph. I love this quote from Abhishek Nagaraj out of Berkeley. Think of data as an imperfect map of the underlying entities. So if you have a number of different data sets and you're trying to pull them together, think about what's really in there. When you carve off all the fluff, let's say that inside there's some entities, some nodes for a graph. There are relationships between those entities. And then there are different kinds of annotations or properties on the entities and the relations. And so that leads into constructing graphs. And when you run entity resolution on a few different data sets, you get output in JSON, which is essentially that, is generating graph elements, entities, relations, and properties. So then we think about constructing graphs. This is taken from that Azerbaijani laundromat case using open ownership and open sanctions and ICIJ. If you just pull the data together and try to link it based off of the records, you end up with really 3 separate graphs for this one subgraph here. And there's an individual, Abasim Bashar, who's definitely central to all this. But once you run entity resolution with some of the less intuitive features pulling together, then it converges into where you have Abasim Bashar as the central part of the graph. And now when you run network analytics, graph algorithms like betweenness centrality, or do some kind of partitioning to understand where the subgraphs are, now you can get much, much better view on where are the people and companies of interest, where are the patterns that might represent fraud, in this case, possible money laundering. There are some great case studies about this from, I mentioned Alan Brown, shout out to PyData Global, definitely Richie at Marigold Analytics. I think that Kinebis is also presenting here, maybe, and Lincurious, we just had Lincurious Days here in London a couple days ago. Anyway, a lot of other folks working in this area have published much about it, and different open source projects as well that are adjacent. Okay, so let me shift into a beyond just constructing graphs. Let me talk in a broader scope of working with unstructured data as well. When we talk about entity resolution, it is based on structured data. And we're looking at this footprint of entities across data sets. The acronym is ER, and that sounds a lot like another acronym, which is NER, which is named entity recognition. That's about unstructured data. So I do want to contrast those. And then there's entity linking, which is where basically you pull the structured data elements and the unstructured data elements together. And so a typical kind of pattern, in the interest of time, I'm not going to go into it, but I provide this here to show working from structured data sources and unstructured data sources and developing graph elements and vector elements, and then having entity resolution really tying it together through the entity linker. And then when you go to use this in a GraphRAG solution, typically you would have a couple of paths of leveraging from the prompt, either leveraging through the graph elements or through the vector elements, and then possibly doing some type of work like a semantic random walk on the back end before you come up with a ranked index of data to feed into your LLM to get better responses. And I'm not going to be, again, in the interest of time, I'm not going to go through, but here's where we spell out a generalized approach for working from, say, schema for which you're accountable for, and structured data, running entity resolution, and then bringing in the unstructured data and parsing it, constructing a lexical graph, and using fine-tuning on entity linking to pull these together within context. There's a tutorial that we have based off of Spacey pipelines. We show this where we go out and we parse a lot of documents, and from the parse trees you get this kind of view. But you can imagine if you take all the sentences in a paragraph and see where they overlap, these parse trees become graphs. And then within that context, going and pulling out the noun phrases and applying labels to them, person, place, or thing. Gliner is a zero-shot state-of-the-art model for that. There's some really, really great work around Gliner, some good tutorials about it here. And it's not an LLM. Actually, bidirectional transformers work better here. But this is a way of pulling nodes out of your unstructured data to add into a graph. Relation extraction is another area where you take co-occurring, the co-occurring extracted entities and you try to find out, is there some kind of semantic or relationship that we can label on top of them? Is there a parent-child or maybe a person in an organization, something like that? And that area still has a long ways to go. I've been using OpenNRE. There's also GliRel, MRebel, etc. I do think this is an area where LLMs actually do perform quite interestingly. But it's about inferring edges. And then there's entity linking to try to pull the pieces together. And I will cut to the chase here. My friend and colleague, Louis Guiton in Berlin, I'll shout out to, recently did some work building a Spacey pipeline component based off of LanceDB, where we take the results of entity resolution that's been run on structured data and use that to create a context. Kind of think of it as like a thesaurus to run through the embedding models in LanceDB to build a fine-tuned, a trained entity linker. So then we can pull the structured data and the unstructured data together in smart ways. And what this, let's see, I'll show you in a minute what it looks like. There's also work on text graphs, again, pulling from parse trees to be able to automatically generate lexical graphs. And I lead a project called PyTextRank that does that. And once you do have a text graph, then you can do different types of graph algorithms to enrich it. And there's also some really good test mechanisms like in Shackle or probabilistic soft logic with PSL for being able to measure the consistency of a graph as you're building it. So just wrapping up here on time, we have a open source playground. It's Docker containers, there's Docker Compose to run, and then you come into a Jupyter environment. If you want to work with some canned environments of how to do entity resolution, or also bring in some of your own data, I highly recommend this. This was just released, I think, last week. And then we have a couple of tutorials that show how to do knowledge graph construction using entity resolution, working from open data. I built one based off of Las Vegas area businesses looking at PPP loan fraud during the pandemic. And then Claire Sullivan took that and extended it with GraphRAG based off of LangChain. So you can talk with a chatbot about potential fraud investigation on that case. And recommend both of those. They're much longer than we could cover here in this talk, but it's all open source up on GitHub. And then there's also another area where we show this integration using Spacey pipelines to take state-of-the-art models at each step and bring in the unstructured data with the structured data And then the entity linking part, where we really blend them together. Louis Guiton built this out, and this is up on, it's actually in PyPy. It's up on GitHub as well. And here's an example of where taking Azerbaijani documents about the Azerbaijani laundromat, you go and you find some named entity recognition, some of the players and some of the organizations, and it automatically links in to the entities that have been pulled out of any resolution from open ownership and open sanctions. And a big picture takeaway is that really what's going on in GraphRAG, it's about this kind of hybrid where the symbolic AI people, knowledge graphs, and the statistical machine learning, LLMs, they're really different camps. I've been in this field for over 40 years, and they really are different camps. But we're seeing areas where you're kind of taking the best of both worlds and pulling together in more hybrid approaches. And I'll defer to Frank van Harmelen, has a brilliant talk about that. And so if you'd like to get involved in this area of like catching bad guys, I would recommend Follow the Money at Open Sanctions. They need help from people who are data experts who are working in open source, want to get working in this whole open data ecosystem for again, chasing the bad guys. So I definitely recommend that. There's also the open ownership has the beneficial ownership data standard, and definitely they would also need some help in advocating for that, other areas to get involved. There are people who are whistleblowers, but also people who are helping build the data at both ICIJ and OCCRP. If you want to learn more about areas like human trafficking, there's a couple of certifications you can do. And we have an organization called Graph Geeks. We actually have a study group inside of Graph Geeks just about investigative graphs. A lot of people who are real experts in this area come and talk with us. And we're trying to put together some projects, some open source projects to help aid in this area. And other community resources, I'll definitely shout out this book in early release by Thomas Bratanek and Oscar Hane. It's called Knowledge Graph Enhanced RAG, which is a really great way to walk you through all the fundamentals. And I've tried to do a webinar series like every month with people who are experts in this area. If you want to get a hold of me, let's connect up on LinkedIn, and I think I'm about at the end. Thank you very much.
Paco, thank you so much. That was a great talk. Yeah, fascinating. And thank you. Much appreciate all of the resources for folks to go and look into. That's extremely valuable. So great. I think we just have a comment. Someone made a comment in chat.
Yes.
Yeah.
Oh, thank you. Daniel, okay, the audio. Sorry, yeah.
No. Don't worry about that one. I think that there's the entity resolution is a hard problem.
One of the few things that open source tools don't really solve very well. Explains. Thank you. Yeah, thank you, Prashant. I really appreciate it. It is interesting. I mean, there's about 50 different vendors in entity resolution. I work with a team. A lot of the core people have been together for more than 20 years. If you've ever seen the movie 21 that stars Kevin Spacey, it's about math students at MIT who go to Vegas and do card counting and then they get busted. So the team I work with, they were actually part of the team that busted them way back when. So what I'm saying is this is a really hard problem where it's actually the edge cases are the value. And it takes years and mountains of data to be able to understand how to handle those edge cases, particularly when you're looking across many different languages. And so that's the fun part, but also the hard part. And that's why open source usually doesn't handle that particular part.
Fair enough. All right, I think that's it. With that, I would say thank you so much for this great talk. And for folks who are online, the keynote will be starting in about a minute. So we'll see you there. If you Paco or anybody, if you'd like to reach out or want to have chat further, you can move over to Discord and watch questions there. So yes, there's a final comment there. Great. Thank you so much.
Thank you, Rob. Chantel,
enjoy the rest of the conference, everyone. You're very welcome. Bye-bye.
Bye.